Flat, mouth-blown window glass has subtle variations. This German company produces a wide variety of mouth-blown sheet glass. It's used to make contemporary wall light panels. It can also be used to make clear or stained glass windows. The company can make glass sheets in 5,000 different colors and textures. This furnace melts silica sand and other natural materials into glass. The starter begins by inserting the end of a blowpipe into a furnace. He takes a small amount of colorless molten glass out of the furnace and rotates it in a wooden mold. The mold is lined with heavy paper to soften the surface. Then he inserts a metal needle through the blowpipe to create a pathway for air. He returns to the furnace for more molten glass. The artisans make multiple trips to the furnace, shaping the molten glass in stages so it's easier to handle. This time, the assistant shapes the glass with a large mold. When the shape is set, the assistant prepares it for blowing. He uses a fork tool to push the glass to the top of the pipe. The starter rotates the glass in a larger paper-lined mold to round it further. The molten glass cools rapidly once it comes out of the furnace. If the temperature dips below 1800 degrees, it's no longer workable, so the team must work quickly and reheat the glass repeatedly. Another assistant lubricates the blowpipe, so it will rotate easily on the support stand. The starter hands the glass over to the master glass blower. First, he rotates the blowpipe to straighten and center the drooping glass. Then he begins turning and blowing into the pipe to gradually inflate the glass. This requires great physical strength, as well as tremendous artistic and technical skill. The pipe and glass weigh over 30 pounds combined. When the glass starts to cool, the assistant reheats it in a smaller oven. He passes the pipe back to the glass blower, who then resumes inflating it. This time he swings it upside down, using gravity to help elongate the shape. Next, he will transform the glass balloon into a cylinder. First, he reheats the tip of the glass and weakens it with the hot burner. Then he reheats the entire glass cylinder. This expands the air inside and forces the weakened tip open. The glass blower taps the opposite side of the hot glass with a cold metal stick. The thermal shock causes a neat stress break. This releases the glass from the blowpipe. Then the assistant slices it lengthwise with a glass cutter and hands it off to the flattening team. Their job is to transform this cylinder into sheet glass. The flattening master's assistant puts the cylinder into a furnace. It's heated to over 1500 degrees. The glass softens in about 30 minutes. Then the flattening master reaches into the opposite end of the furnace with a stick and gently opens the cylinder. Next, the flattening master irons the glass sheet with a special wooden tool. The flat sheet goes into the annealing oven for a gradual controlled cool down. This relieves stress and prevents cracking. The flattening master's assistant removes the glass from the annealing oven and performs a visual inspection. The last step is to cut the edges straight. To make multicolored and textured glass, they add additional ingredients during the melting process. Mouth-blown window glass contains natural variations that play with the light and create a subtle glow. A glow that machine-made window glass can't replicate. Using urn-shaped castings,
This is for a water
One
pump.
turbine pump
How to make
could
a
have
water
up to
pump.
30 diffuser bowls. The bowls hold the pump's spinning impellers. Computerized tools refine their shape, so the bowls fit neatly in the pump column. Another set of tools carve the bronze impellers. They fine-tune the casing so that the impellers will fit into the diffuser bowls. Here's a look at both sides of the finished impellers. An uneven impeller will vibrate when spinning. A technician uses this machine to check for imbalances. When sensors locate the problem, he sands down the metal in that area. This balances the impeller. Next, a machine carves the top attachment ring of the discharge head. The discharge head shields the motor from water. It also changes the water flow from vertical to horizontal. Next, a machine carves the outflow flange and drills holes for attaching a gasket. An employee paints the part blue. The paint protects the metal against rust. He also highlights the embossed company name with bright red paint. Here are the machine parts before and after painting. Next, they make the pump shaft pipes. Tools work on both ends of the pipe simultaneously to refine the inner diameter. Then they carve threads into them. They clean the pipes, then roll them into the holding area. Next, computerized tools cut threads into the bronze bearings. These threads will interconnect with the ones on the shaft pipes.
What'd you drink?
A worker screws the completed bearings into the ends of the shaft pipes.
You already got some water?
Yep.
Then he screws the pipes together in a loose pre-assembly. He brushes lubricant onto the exposed section of the bearings. He links 4 pipes to create one 20-foot pipe. He sets the long pipe in a cradle-like device and activates the drive wheel. As the pipes tighten, the bearing disappears inside. The worker inserts a steel shaft into each 20-foot pipe. He caps the ends to secure the shafts inside the pipes. This wider pipe is called the column pipe. An employee attaches an assembly flange to each end and secures it with bolts. A worker connects a suction bell to one of the shafts. The suction bell will draw the well water into the pump. Then he slides an impeller into place. He secures the impeller to the shaft with a tapered clamp called a collet. He encases the impeller in an iron diffuser bowl. He bolts the diffuser bowl to the suction bell. They add more impellers to increase the power of the water pump. A more powerful pump will be able to extract water from deeper underground. They apply protective paint to the pump, and then it's ready to install. On site, workers use special equipment to help guide the pump into the well. They join the shaft pipe to the pump. Then they slide the column pipe around the shaft pipe and bolt it to the top of the pump. The team adds more shaft pipe for a deeper reach. Then they install the discharge head. This turbine pump is now ready to extract water from great depths underground.